Hi folks, my name is Ms. Midha, and today we are going to focus on the following question. How do we describe the distribution of different data sets? So we are going to be looking at 4 different data sets, one at a time, and essentially describe their distribution. So here we go. All right, this is our first data set. It says, each student in the class measures the length of their step in centimeters, then walks across the room counting the number of steps to estimate the length of the classroom in centimeters. And your job is to describe this distribution using the terms symmetric, skewed, bell-shaped, uniform, and bimodal where appropriate. Now, what I encourage you to do after I present each data set, I encourage you to pause the video and see if you can figure out how to describe each distribution. Whenever you think you have it, then just go ahead and unpause and we will continue to review. Okay, now if I look at these terms, symmetric, skewed, bell-shaped, uniform, and bimodal, and then I look at my actual data set, well, I notice that there definitely appears to be this bell-shaped curve, right? I can see sort of, if I almost just trace it, it definitely looks like a bell-shaped curve. So I can see right away that bell-shaped would be a word that I would use to describe this distribution. And if I also look at this some more, I notice that this is pretty symmetric, right? If I think of 762, kind of as that center, and I look at everything to the left of 762 and everything to the right of 762, they're pretty much symmetric to each other, right? They're like a mirror, they're mirroring each other. So I would say, to describe the situation, that this distribution is symmetric and bell-shaped. So those are the 2 descriptions for this distribution. All right, the next one. As a test for fitness, students are asked to do as many push-ups as they can without stopping. Okay, now if I look at this data set, it's definitely not symmetric, right? It's definitely not symmetric, and it's definitely not bell-shaped. I don't see any bell-shaped curve. Now these other terms, let's sort of review what these other terms are. Okay, skewed. Now when distributions are skewed, they're skewed left or they're skewed right. And if they're skewed left, what that means is that there are fewer data plots that are found to the left of the graph. Right? So there are fewer data plots toward the smaller numeric values. And when we're talking about the smaller numeric values, we're talking about around here, right, to the left of the graph. And I can see pretty much, yeah, this definitely does look skewed left, right? There are far fewer data plots found to the left of the graph. So this is going to be skewed left. And what else do I notice about this data set? Well, it looks bimodal. Now, what does bimodal mean? So a data set is bimodal if it has 2 modes, right? So there's really not a single data value that occurs with the highest frequency, right? There's 2 data values that tie for having the highest frequency. So for this data set, we would describe the distribution as skewed and bimodal. And to be more specific, skewed left and bimodal. Okay, next one. A group of 30 students are asked how many times they eat a meal not made at home each week. All right, again, definitely does not look symmetric, definitely does not look bell-shaped. I can see, though, that it's skewed, right? It's definitely skewed again, but in this situation, it's actually going to be skewed to the right. So it's skewed right because fewer data points are found to the right of the graph. Fewer data points are found toward the smaller numeric value, toward the larger numeric values. So this is going to be skewed right. Now, what else can we say? Well, what is uniform, by the way? Right? Uniform means that in each value, it has exactly the same frequency. And I can tell here that it is not uniform, right? Not every value has exactly the same frequency. So it's not going to be uniform, but it does look bimodal again. Again, what does bimodal mean? It has 2 modes. And if I look very, very closely, I'll notice that the 2 modes are at 0 and 6, right? So there are 2 different modes here, which makes this bimodal. All right, now for the last one. A company sells small colored erasers in packages of 24 erasers. 30 packages are inspected and the number of red erasers in the package are counted. So again, just like the last 3 data sets, pause the video, see if you can figure out what you would use to describe this distribution. Okay, now this one is definitely a little bit more tough than the others, right? Because it's hard to describe because it doesn't look like any of these almost. There's something wrong with each one of them. But if you look closely, it does look close to uniform. It does look close to uniform, and it does look close to being symmetric, right? So I know it's not skewed. I can like immediately just cross that out because it's not like it's not having fewer data plots found to the left or to the right of the graph. I know it's definitely not bell-shaped. There is no bell shape that's being created here. And I know it's not bimodal. But I can see that it is approximately uniform and symmetric. So notice that we're using this word approximately now, right? Because essentially when we're saying something is approximately uniform, it means that instead of each value having exactly the same frequency, they all have frequencies that are almost exactly the same, right? We can see that in so many of these number of red erasers in the package. A lot of them have almost exactly the same frequency. So it is approximately uniform. Now, why did I write approximately symmetric? Well, it's not exactly symmetric, but it is very, very close. All right. It's not perfectly symmetric. It's not like a spitting mirror image of each other, but it is approximately symmetric. All right, so we had 4 different data sets, and we were able to describe each of their distributions using the terms on this list. So just to recap, what are these terms? What do they mean? Well, these were our 5 different terms, right? Symmetric really means like it's almost like a mirror when something is mirroring off of each other. So it's symmetric about something. Skewed means, well, when something is skewed left, fewer data points are found to the left of the graph. If it's skewed right, fewer data points are found to the right of the graph. So with the left, fewer data points are found towards smaller numeric values. Skewed right means fewer data plots are found towards the larger numeric values. When something is bell-shaped, it creates that bell-shaped curve. Uniform means that each value has exactly the same frequency. And bimodal, it means when a data set has 2 modes.